All right, so we're going to go ahead and get into this section of notes for today. So we are starting our last unit of the year. This is going to be Unit 11. So if you've not already, feel free to find a clean sheet of paper in your notebook. And then this is going to be Unit 11, and in this unit we are talking about circles. So you can go ahead and label that, and then you can label today's notes. Today we're getting into 11.1. We're talking about circumference and arc length here. Okay, and date that we did this is going to be the 30th here. Okay, our objective for today is we want to be able to look at a circle and we want to be able to find the circumference of it, which hopefully is review for some of you, or at least hopefully you've practiced a bit in the past. If not, then you'll just get some new information. And then some new things that we're adding in here is we also want to be able to find the length of an arc, and we'll talk about what that looks like in the notes. So first off, just getting the basics down, making sure we understand. Again, hopefully this is just review for a lot of you. Obviously we know what a circle looks like, but just for the technical geometry definition, is the set for a circle is the set of all points that are all equidistant from the same point. Okay, this is just a different way to describe or define a circle, is the set of all points that are all equidistant from the same point, which in our case, or in any case, is going to be the center of that circle, right? Okay, and then one other thing that hopefully you've heard of before, the diameter. Okay, we kind of already talked about this a little bit in our area unit when we were dealing with radius. So just as a reminder, definition for diameter is we could say the distance from one end of the circle to another. And specifically we'll say this, the distance from one end of the circle to another that crosses through the center. Okay, so just the basics here. Understanding what the center is, and then just understanding, or just a little review of what the diameter is. It has to go all the way across the circle, and it has to go through the center. Okay, so with those two things, we're going to use that to find what's called the circumference of a circle. And so I'll write this down just in case we are not aware. First off, the circumference of the circle is just the distance around the outside. Okay, and really we could say the total distance around the outside here. So just in case you're not aware of what the circumference tells me, the circumference is essentially the perimeter of the circle, the total distance around the outside. Okay, and our equation for that, you guys might have learned a mnemonic device with this, but the equation, we're going to say circumference equals pi times d, with d being the diameter. So I'll go ahead and put that to the side. D is diameter here. And then I'll go ahead and circle that because as a reminder, anytime we see an equation or formula in our notes, it's usually good to kind of circle that and make sure that stands out here. Okay, so with d being the diameter, it's just pi times the diameter. And this is kind of where pi came from, actually, is when mathematicians were creating circles and they were looking at the distance across, they noticed that it always had the same ratio over and over again. It was always this weird number, 3.1415, so on and so forth. And so that's why they came up with pi. And so in general, we've worked with pi before when we talked about area. Now we're just using the same kind of idea with circumference here. Okay, so first one here, example 1. Let's get the basics down. Find the circumference of the circle here. So if we're looking at this, you'll see this is the way that our textbook likes to present these kinds of problems. A lot of the time, they won't just give you the diameter or the radius, but they'll give you a shape that is inside of the circle or inscribed in it. And you have to use the information that you know about that shape to find, usually the diameter. So in this case, we have the circle here. We have this triangle inside. So as a reminder, if I want the circumference, I need the diameter. And the way to do that, in this case, if I want the diameter here, we'll just label this D here. We see this is a right triangle, so we can use the Pythagorean theorem. So we'll say 8 squared plus 15 squared equals our diameter squared here. Okay, and again, that's the hypotenuse of that right triangle. So we can go ahead and simplify. 8 squared is 64. 15 squared is 225. Continue to solve here. So 64 plus 225, that's going to be 289 equals diameter squared. And then last step, we've done this before, just take the square root of both sides. And so I'm left with my diameter here. And if you didn't know this one, you can just obviously type this into a calculator. But square root of 289 is actually going to come out to be a whole number. That is going to come out to be 17. Okay, so our diameter here is 17. And now last step, all we need to do if we want to find the circumference is we just plug that into our equation. So our circumference equals pi times our diameter, or in other words, pi times 17. And so I would just type this into my calculator and see what I get here. Obviously, it's going to be a decimal since we have pi in there. So we're going to say the circumference is roughly 53 point, and then we're going to just get in the same habit of rounding these off to the nearest 10th place. So 53.4. And then like we kind of discussed when we were talking about area and volume, usually a good idea to include units if you have those. In this case, since it's just the distance around the circle, the unit is just going to be centimeters. Okay, so just like you would do with perimeter, you don't need to square your unit or cube it. It's just going to be whatever the unit is. Okay, so that's just the basics. Like I said, hopefully that's a little bit of review. And just as a way to kind of keep track of the equations that we used last time or in our last unit, a little trick for remembering, the two different equations with circles is cherry pies delicious is what we say for circles, and then we say apple pies are two. Okay, so that's just a way that you can remember those two. Cherry pie is delicious. That just means circumference equals pi times d. Okay, and then area, same kind of idea. Apple pies are two. Okay, so that is with circumference. Other things that we need to talk about here that are also going to be hopefully straightforward is just the idea of a central angle in a circle. Central angle. Okay, so definition of this, a central angle is an angle inside a circle whose vertex is the center of the circle. Okay, an angle inside a circle whose vertex is the center of the circle, or the point that all other points are equidistant from. Okay, so for example here, we've actually seen this when we talked about different sectors and we were finding area. So we'll do our best attempt to draw a circle here. And all I need is an angle, so two rays or two lines that are going from the center. So for instance, here and here, this right here, we'll just call it x. Okay, that would be an example of a central angle. And like I said, we actually already saw these when we were working with area and we were doing area of a circle and area of a sector. Okay, and then one other thing here as well. And we hopefully we understand this, or we can talk about this a little bit, but the sum of central angles, if we're thinking about what all the angles around a circle would add up to, or that degrees, the sum of central angles will always be 360 degrees. Okay, so just a little refresher there, a little reminder. All the central angles are always going to add up to 360. Okay, so for example here, again, draw a circle. So just as a reminder, we can kind of see how this plays out here, where if I created a 90-degree angle, that would give me a quarter of the circle. If I created a straight line, that would be 180. So we'll go 90 right here, 180. If I go all the way, keep going most of the way around, 270 down here, and then all the way around would be back to 360. Okay, and you guys will actually use this idea in Algebra 2 as well when you go over something called the unit circle. But just understand that measure of all the angles are going to add up to 360. Okay? All right, so putting that to use here, example 2. Let's say we have this circle and we want to find the measure of angle x here. Okay? So simple enough. If I want to find this measure here, I just know all four of these angles on the inside, all these are referring to the central angles on the inside, are going to add up to 360. So I'm going to say 40 plus 85 plus, we know this denotes a 90-degree angle, plus x equals 360. And then just solve this equation. So we can combine our like terms here. 90, 40, and 185. I believe that's going to come out to be 215. Yep, 215 plus x equals 360. Just double check. Yep. And then last step here, subtract 215, and I get x equals 360 minus 215, which is going to be 145, or 145 degrees if I want to be more specific. Okay, so we've seen a lot of problems like this in the past where I just have to add up all the numbers to something. In this case, that number is just going to be 360. So not too crazy here. Okay, one last thing that we need to talk about today is finding just smaller distances around a circle instead of just one part of the angle or the entire circumference. And this is where we get what we call the arc of a circle. Okay, the arc of a circle. All right, in this definition here, arc of a circle is a portion of a circle, okay, a portion of a circle that is defined by two endpoints. Okay, a portion of the circle that is defined by two endpoints here. So, for example, what do I mean when I say a portion of this? What does this look like here? Let's say we have an example where I draw a circle here, okay, and I'm actually going to try to use a different color here, and let's say we break this circle up. So let's say we have this right here, go here and here. Okay, so when I have this central angle here, this gets broken up. There's one piece or one portion of the circle that is right here. Okay, and let's say this is, we'll call this x and we'll call this y here. So this arc in red here, what I would call this is I would call this arc xy. Okay, so this is what this arc would be called. This is the arc of the circle, or in other words, it is just this distance of this piece right here. So if I just was kind of walking around the circle and I traveled from x to y, that would be the arc xy there. Okay, it's the distance on the outside, or that portion that's defined by those two endpoints. Okay, and then notice technically we could also call the other side here, this other arc, we could also call this xy as well. But usually when we call an arc something or referring to that, we're always referring to the shorter of the two, or the smaller of the two. So really when you're looking for this, you're just looking for the angle measure to be less than 180, because that'll always give you the smaller of the two arcs that you have. And usually they'll be defined pretty clearly for you, okay? So that's just what it is. Arc is just the distance around the outside, just a portion of that. And if I want to find an arc length specifically, we can write this down. Okay, what is that exact distance? Well, what we want to do is we want to take our entire circle. So I'll say arc length here. We'll just call this L. Okay, usually it's just denoted by a cursive L here. Arc length is going to equal, well, first off, what if we found the circumference? Because that would give us the entire distance around the outside. So we could say that's pi times d, or what our book and what mathematicians usually use is they usually have the radius. So they just do 2 times the radius, or 2 pi r. Okay, 2 pi r is the exact same thing as pi times the diameter, because we're still just multiplying the radius by 2. Okay, we just reorder things around. So this would give us our circumference, and then if we just want a portion of that, kind of like the definition says here, it's going to be related to this angle in the middle here. So that angle, and I'll go ahead and draw that in red, that angle here, we'll just call that x, is a part of the circle. And so what we're going to do is we're going to take our circumference, and then we're going to do x over 360. And this is our definition, or this is our formula for arc length. So it's a very similar idea. When we were looking at sectors, we took the area of the circle and then we multiplied it by x over 360 because we only wanted a portion of the circle. Same idea here. I know 360 all the way around, so if I just want that arc length, I just want a portion of that, and I just want the angle measure that I'm given. So in this case, we'll say x is going to represent the given angle measure here. Okay, so very similar idea when we were talking about area of sectors in 10.1. Okay, so last example here, kind of practicing this a little bit, making sure we understand what it is referring to here. Let's say we're given this circle and we want to find the length of YZ. So length of YZ here. So I'll go ahead and label that on my picture. Okay, it wants us to find this curve length. Okay, and this is a nice equation that we can use, because usually when you get into finding lengths, once you have curved lengths, things get a lot more complicated. So it's nice that we have this equation here that we can use to make it a little bit easier to find that. Okay, so with this here, I'll write out the definition, or I'm sorry, the formula, just to make sure we understand and remember. If I want to find the arc length of an arc, I want 2 pi r times x over 360 here. So we can look at this. So in this case, r, if we wanted to find that first, that's just the radius. So we're given the diameter is 10. So as a reminder, radius is just going to be half of that. So it's just going to be 5. Okay, or you could just use the diameter as well and just not multiply by 2. Okay, but radius is 5 here, and then x, remember, x is always going to represent the given angle measure. In this case, that given angle measure with this arc is 130. So 130 here. And now all we need to do is plug these into our equation and see what we get here. So I have length equals 2 pi times r, in other words, 2 pi times 5. So that is going to end up going back to 10. And then times 130 over 360 here. Okay, so just plugging into our equation, x is 130. Okay, so now we have 10 pi times, and if I wanted to, I could simplify this down, 130 divided by 360 here. That's going to give you about 0.36 and then 1 repeating. Okay, or another way that you can do this, if you get to this step, where you have 10 pi times 130 over 360, what I would do in my calculator is I would start with 10. I would multiply by 130. So, I'm sorry, yeah, multiply by 130, and that would give you 1300. And then divide by the number on the bottom. So divide by 360 here. And that gives you about, okay, similar kind of number that we saw before. This equals 3.61 repeating, and then times pi. So then I would multiply that number by pi here. And so final answer here, just the distance of this arc here, of this curved piece, is going to be about 11 point. And then again, if we're getting into the habit of just rounding out to the tens place, we'll just say 11.3. And then distance is still going to be, or unit is still going to be centimeters. Okay, so that is all the notes for today, dealing with circumference and arc length. Homework for this is going to be 11.1, and that should be posted on the class website. And as always, if you guys have any questions, feel free to let me know. All right, thanks guys.